Hi, I'm Aiden Geiger, and this is my second project on U substitution. Okay, so the first problem is pretty simple. The best thing I've learned for U substitution so far has probably been where to find U. It's like the most important thing, and when to recognize to use U substitution. So the best rule of thumb I found is look at the second parenthesis, and or if it's like a square root or something, pick the square root. And the reason why we need to do U substitution is because we can't do anti-chain rule, or it's just super complicated, and U substitution is just easier. So our first problem, we're going to find U. U is just this right here. Simple. So we get U is equal to 4x squared minus 12. Oh, forgot an x there, but that's okay. 12x. Okay, so we found our U value. That's that value in the parentheses. Now we need to find du, which is equal to 8x minus 12 dx. Now, since we want to also be substituting for dx, we need to find dx. So we're going to divide both sides by 8x minus 12. 8x minus 12. So we get dx is equal to du divided by 8x minus 12. Oh wait, this does not have an x. Whoop, that was a little bit too big of an eraser. There we go. Perfect. Okay, so now that we found d of x, whoa, what's that? Okay, now that we found d of x, we can substitute back into the original equation, and we can do some u substitution. So we'd get integral of 8x minus 12 times u to the fourth power, because it's up there. Boom. And then we're substituting our dx value that we just found back in, so we'd get du over 8x minus 12. As you can see, these two values will cancel, leaving us with the integral of u to the fourth power. So now we can just take the regular antiderivative. So you do 1/5 we can just write u to the fifth power plus c. So now, since we found our final antiderivative value, we can just simply plug back in our u value that we found up here, and that will give us the antiderivative, or the integral, of our original question. So our u value is just 4x squared minus 12x. So you get 1/5 times 4x squared minus 12x to the fifth power plus c. And that is our final answer for that question. Okay, let's try another one. These are pretty easy and fun, but are also kind of complicated sometimes and are confusing a little bit. So the more practice you do on them, the better. So, second problem. A little bit different because we got negative exponents, but still pretty simple. Same thing, we're going to find u, which is this value right here. Bam, we got it. So u is equal to 2 plus 4x to the negative third. Now, same steps. We're finding du again. So we're taking the derivative of this value right here. This 2 will go away. So we get negative 12x to the negative 4 dx. Then we're dividing both sides by negative 12x to the negative 4. Simple. Then we would get dx is equal to du over negative 12x to the negative 4. Okay, same step as last time. We're going to plug dx back into this dx. And we're going to plug u into this right here. So we're going to get integral of 3x to the negative 4 times u to the negative 7 du over negative 12. Oh, actually, we're going to take out a negative 4, and then we're going to be left with 3x to the negative fourth power. That'll just make it simpler to cancel. So now that we have that value, it's the same thing. This is the same thing as that. It just has the 4 on the outside. It'll just make it easier to cancel. Just makes it easier to see. So these two values will cancel, and we're left with u to the negative 7 du over negative 4. So now that we have that, we can bring this 4 to the outside. So we would have negative 1/4 the integral of u to the negative 7 du. So now we can just take the antiderivative of this inside term. So we'd get negative 1/4 times. So we're adding 1 to that, so we're actually subtracting from the 7. So you'd get 1/6. You get negative 1/6, my bad. U to the negative 6 plus C. Okay, now we just times these two together. So we're just doing distributive property. So you get 1/24, because it's negative times a negative equals a positive. And then we would plug in our u value, which is up here. So we get 2 plus 4x to the negative third to the negative sixth plus c. And that's our final answer for question 2. Easy, got this. Okay, now for the third problem, there's cosines and sines. So you need to know a little bit of trig, but not a ton. And the antiderivatives of these are pretty simple, so we're chilling. Okay, so we would have the integral. Oh, I'm in green. My bad. So, same thing. We're finding u again. So what is u in this case? The second parenthesis. Nice. Okay, so u is equal to sine of 3x minus x to the third. So now we're just going to find du. So the derivative of sine is just cosine of 3x, and then we need to do chain rule, so times the derivative of the inside term, which is just 3 minus the derivative of this, which is, and we're putting all this all in parentheses, 3x squared, boom, like that, and then dx. Perfect. Boom. Okay. So now that we found du, or we still have to find dx. So we know what du is equal to. We're just going to divide this whole thing by 3 cosine of 3x minus 3x squared. Do the same thing on the left side. 3 cosine of 3x minus 3x squared. Boom. Easy. So dx is equal to du over 3 cosine of 3x minus 3x squared. Bam. Got it. Now we can plug this back in for our dx, and we can plug u in for that. Okay, so we're going to do integral of cosine 3x minus x squared, bam, times u to the 5th power, and then our dx value is this value right here. Easy. So you get du over. We're going to take 3 out because it has 3 right here. It has a greatest common factor. It'll just make it easier to cancel like that, just like we did in the first problem. So cosine of 3x, oh, forgot a 3 here, minus x squared. Bam. Now we can see that these two terms cancel. Let me put that in red. Bam, bam. Just like that. Oh, I did not forget a 3 there. Whoopsies. Okay, so now we have left over with the integral of u to the 5th power times du over 3. So now we can just bring this 3 to the outside like we did last time. So do 1/3 integral of u to the 5th power. Now we're just taking the antiderivative of u. It's pretty easy. So you get 1/3 times 1/6 u to the 6th power. Bam. Now we can just plug in u, which is simple. So we would plug in u, which is our value up here. So you get 1/3 times sine of 3x plus, oh, my bad, minus x to the third, and that's all to the sixth power plus c. That is our final answer right there. Easy. Okay, last problem. We got this. So, same thing. There's a square root right here. So, that is the value, that is u. Easy, we found it. So, u is equal to x squared minus 8x. Bam, got it. The u is just the derivative of that. So, 2x minus 8. And then dx. Now we got to find dx. So, we divide both sides by 2x minus 8. We get dx is equal to du over 2x minus 8. Easy. So now we can just take the integral again. We can plug everything back in. So we get 5 times x minus 4. And then this is just u to the 1/3 power because it's a cubed root. And then dx is equal to this value that we just found. So du over 2x minus 8. And actually, we're going to take out a 2. So it would be 2x minus 4. There we go. Now these cancel perfectly, just like that. And since we have the 2 on the bottom and the 5 over here left over, we can just bring those to the outside. So it would be 5 divided by 2, the integral of u to the 1/3 du. Perfect. Now it's just a simple antiderivative. So we can do 5 seconds times. So we'd bump this up by 1. So if you add 1 to that, you would get 4 over 3. But since we are dividing that, it would actually be 3 over 4 u to the 4/3, just like that. And now we can plug our u value in, which is x squared minus 8x. Or let's multiply these first, actually, it would be simpler. So now we would get 15 over 8. And then our u value was x squared minus 8x to the 4/3 plus u plus c, my bad. There we go, that is our final answer, and we're done. That was all 4 problems. And yeah, they weren't too complicated, not too hard, but I hope you learned a little bit about u substitution. Okay, bye.